How's it, guys? Today I'm going to talk about vector sorting and searching. So what we're going to do is sort a vector and then find where elements would fit in this sorted vector. So the story behind this is that we have a list of students and they're all sorted by surname. So they have a student number, a name, and a surname. And it's all sorted by surname, but we actually want it to be sorted by the student numbers. So what we need to do is read in this information into structs. And just one of the conditions is that I'd like the struct to have a constructor. And then once we've read them all in, we need to create a function that sorts the vector according to student number, but in ascending order. Okay. Then the next thing that we need to do is open the next file of other student details that don't exist in this vector. And these are the students that we're searching to see where we would need to put them. So what we do is we use the iterative search algorithm and the binary search algorithm and compare the two to see which one's better. And what we'll find is that the binary search algorithm should take a lot less time to find where someone should be inserted than an iterative search, which means that we just run through the whole thing. Here is the input file. This is what it looks like. It's got the student number, the name, and the surname, and you'll see that it's sorted by surname. And we have, about 11,500 students in here. So it's a lot of students. And the search file is not sorted at all. And basically what we need to do is find where this person or this student would fit given this student number. Okay, so let's start off with the main.cpp. It's the normal main.cpp template, and we're going to need to add a few more things. We're going to be reading in from a file. We're going to have a vector. That vector is going to have students which have name and surnames which are strings. And what else? We're going to need to sort, so we're going to use the standard algorithm library. Okay, cool. So let's start off with creating the student structure. What we need to do is create a structure that has a name, a surname, and a student number, right? So let's start off with the student number. We need that. We need a name, and we also need a surname. Okay, and like I said, I'd like it to have a constructor as well. So let's create the constructor, and we're going to have in the constructor we're going to be sending in, I'm going to call it init student number, I'm going to call it init string init name, and string init surname. Okay, now you can call these variables whatever you want. It doesn't have to be init or whatever. You can call it what you want. And what we would do then is we'd set student number to init student number. We would set name to init name, and we would set surname to init surname, right? And what I'm going to do for efficiency is I'm going to send these variables by reference, by constant reference, so they can't be changed, but they are not created again in memory. And then on top of that, if we really wanted to be efficient, right? So we didn't want to create unnecessary time, basically waste unnecessary time. We wouldn't actually construct these variables, the number, name, and surname, in the constructor. We'd do it during the constructor while it's running. So basically what we'd do is we'd say the student number should be constructed with init student number, and then we'd have stuff like the name would be constructed with the initial name, right? And we could do that the same with the surname. The surname would be constructed with initial surname. And now what that does is, instead of creating an integer, a string, and making them all empty and then setting them to these initial values, it would from the start construct an integer and give it that value, construct a string and give it that value, which is slightly more efficient. So we'll leave it for now just with the simple way of just setting each variable. But now we have a struct that can be constructed. So let's now create a vector of students, and this vector will contain all of the details of the students in that single file. So we're going to need the input file, right? Input.txt, and we're going to need to read in the student number, we're going to need to read in the name, and we're going to need to read in the surname. And my favorite way of reading in from a file when we don't know how long it is using while. The input can read into the student number, the name, and the surname. Keep reading, And so this will run as long as this information exists in the input file, and it will keep running through. And each time we get a new student, we're going to need to push that student back to the student's vector. Right, so we're going to push back this new student, and we've got a constructor now. So basically we're going to construct a structure, and we're going to need to send in the student number, the name, and the surname. And that's it. We've now created, well, we've taken all of the information from the file and put it into this vector. The next step is to sort the vector. We need to sort the vector according to student number, not according to surname. So I would like to use the standard sort algorithm, and I would say sort students.begin and then comma students.end. And I've recently posted a video about vector sorting. Right now, your program doesn't know how to sort a student. What makes one student greater than the other, or bigger or smaller when you do comparisons, or equivalent to? It doesn't know. So what we need to do is create a function. I'm going to call it bool comp, and what it's going to do is compare two students to each other. So student LHS and const student RHS, right? And basically what we do is we return whether or not these things should be swapped. So LHS dot student number is less than RHS dot student number. And the way I like to think of this, right, of how to know if this must be greater than or less than, is if you send in this function and you return true, it means leave everything as is, and if you return false, it means swap them, right? So if we return a student number that's smaller in the LHS than the RHS, that will return true, so they'll be kept the same, right? It won't swap them around. If LHS is greater than RHS, then that will be false, and it will swap them around, and that's quite a cool way of doing it. Now what we do is we take this function name and we paste it into here. So what we do is we say, I want to sort the students vector from the beginning to the end, and I want to use the comp function to compare students. This will now be the metric that it uses to compare students. So by the end of that, we now have a sorted student vector, a vector of students sorted by the student number, and it's in ascending order. Okay, so now what we need to do is we need to open up this new input, right? And it's going to be called search.txt, and it's got student details that we don't actually know. Well, they're not in the vector yet. And we're going to create an output file, output.txt as well, where we'll output the index that where they should be inserted. Okay, so the first thing is to read in from the search file, and we're going to read it into the student number, the name, and the surname. Okay, cool. So we're reading while we can still read into these variables. Keep going. And now what we want to do is find where the student should be placed. So we've got a file or a vector that's sorted by student number, and we want to find where this person's student number should be in that vector. But we're not going to actually put it there. So we're going to use two different searches. The first one is the iterative search, and so we're going to do iterative search. And but the way I'm going to do these searches is int is going to be the index where the person should be put. Okay, so let's say 1,000 or 2,000 or whatever the index in the vector where that person should be put, and I'll tell you the rest now. So what we're going to do is we're going to send the vector of students, and I'm going to send that by a constant reference so that we don't have to recreate it each time. We're also going to need to send the student number of the current student that we're searching for, where that student number should be inserted into this vector. And finally, I'm going to send by reference a variable called iterations. And what that's going to be is it's going to be a count of how many iterations it took to find where the student number should go. So let's start off with what we're going to do is let's just set iterations to 0. Okay, and what we're going to do is with the iterative search, it just runs through the whole vector from 0 all the way to the point that this student number should be. So basically how we know where this person should be inserted is if the current student number that we're looking at, this one here, is greater than the student number in the vector, the current vector position, then we keep moving until it's no longer greater, because when it's no longer greater, it means that it should be inserted there, and that student number that's greater should be pushed up by 1. So what we're going to do is we're going to do unsigned int I equals 0. I does not equal the student's vector size, I plus plus. And what we're going to do is we're going to say, okay, if the student number is less than students dot at I, so that means we're at a current position in the student's vector dot student number. So we're comparing student numbers here. If it's less than that, then we know where we should be right now, right? So we're going to set the iterations to I, and we're also going to return I, basically. That's it. And that's it. If we get to this point, we know that we're at the right point. So the iterations we've compared, we've done I comparisons between student number and this vector, because every single time we run through the vector, we do a comparison. That's why the iterations will be equal to I. Otherwise, we return that, and we return I as the index as well. You'll understand this more when you actually do it and understand what the iterative search does. What happens if we get out of this for loop and it was never less than any of the students? Basically, then the iterations is going to be equal to the students dot size, right? And we're going to also return the students dot size, which is here we go, students dot size. So that's it. Now we know the position where the student number should be placed. Okay, the next one, the next search, is the binary search. I'm going to do this in two different ways. I'm going to do this iteratively and recursively. So the binary search, what we're going to need for, I'm going to call this, let's go binary search iterative. And so if we want to do an iterative search, this is all the information we're going to need to send again, right? The vector of students, the student number, and the number of iterations. Okay, cool. Now, what we need to do is we need to remember how binary search works. It uses an upper bound and a lower bound. The let's put the upper bound or the lower bound, unsigned int lower, is equal to 0, right, at the start, and unsigned int upper is equal to our students dot size. Okay, that's our upper bound. We can't go higher than that. At students dot size, we're at the end of the vector, and if something needs to be inserted there, that means insert it right at the end. And then we're going to need unsigned int mid, right? Okay, so now what we do is let's do something like this: bool found equals false. Okay, while we haven't found the right place for this to be, we're going to need to run through this while loop. And what we need to do is we need to say that mid is equal to our lower plus our upper bound divided by 2, right? So that means we're just taking the midpoint between the lower and upper bounds. And we need to compare that, and we need to say, okay, is the vector here, this vector point, or the student in the vector, is that student number greater or less than the current student number? So the best way that I like to do this is basically I'm just going to go if the students dot at mid dot student number is greater than our current student number, then what does that mean? Okay, if it's greater than that, then it means that in the vector we're too high up, like we can actually pull the upper bound down, right? So that means that upper now becomes mid. Okay, else if the students here is less than the student number, what does that mean? It means that the current position, our lower bound is far too low, so we can set our lower bound equal to mid. Okay, else what if it's equal? So that's a very special case, and in our case it will never be true because the student should not be in that file. But if it is, we'll return the number or the index, which is mid. Okay, what else is there? So if it's greater than, we're going to shift the upper bound down. If it's less than, then we're going to shift the lower bound up. And then we do the final checks. And now what we need to also do is make sure that the upper bound minus the lower bound is not equal to or less than or equal to 1, because when they're just one apart, it means we're in the right place. So we just go found equals true, right? And that should be it. This should actually be here. Let's just put this over here. So if because we can do this check right at the start, and then we can just continue to the end, and we'll get out of the while loop. And that's it. So now what we do is we set our middle variable. We then do the comparisons, reset our bounds, keep running this while loop until we get to the point where our upper minus our lower are close together, and once they're only one apart, we know that's where we should be. Now the thing is, we need to count the number of iterations, right? So we set iterations to 0. Every single time we do a check, we will need to increase our iterations. So here, iterations plus plus, and in these two cases, we'll also just increase the iterations, but we can put that over here. We don't have to paste it in both of these, because if it does this if statement, it will go here. If it does this if statement, it will go here. The only reason I've put iterations plus plus here before I return is because once I return, it will never run this line. Okay, cool. So now we've run through this while loop, and we all have found a position where the student should be, and we've got the number of iterations. We're tracking that. Okay, cool. So that's the binary search algorithm, but that's the iterative search. Now let's do a recursive search of the same type. So with the recursive search, we won't be running through a while loop. We'll actually just be calling this function over and over again. So what are we doing? We're searching for the students, the student number in the student's vector, and we've got a number of iterations that we're trying to do or trying to reduce. What else do we need to send? We need to send the upper bound, and let's make it an unsigned int. Unsigned int upper and unsigned int lower, and I think that's all we'll need. So let's just think about it. Okay, we need to do a check. We need to say that our unsigned int mid is equal to upper plus lower divided by lower divided by 2, right? So we've got our middle point. Now what we do is we check, and we do the same checks as what we did in this function as well. So let's take a look here. Boom. Okay, if the students at the middle, this mid value, is greater, then upper equals mid. If it's less than up, and then lower equals mid. Else, if it's equal to, then we return mid. Okay, so that's cool. Now the trick is here. Instead of saying upper equals mid, we need to say return. Then the binary search, but this now must be recursive. Return binary search recursive. We're going to need to send the students, that's the vector, the student number that we're searching for, the number of iterations, plus plus, because we're increasing now. Then remember, we set upper to mid, so now upper becomes mid and lower remains lower. And in the same case, we need to do for this one, lower becomes mid, right? So this now becomes mid, and this one remains as upper. Okay, cool. And that's about it. Now the last thing that we need to do is we need to know, okay, what happens if we're at a point where upper minus lower, the difference between them is 1. So what if upper minus lower is less than or equal to 1? Well, if that's true, then we're at the right place. So we'll just say that return I think it's the upper one, return upper. Because now, when, let's just think, upper plus lower, it's actually going to be lower. Return lower. So that's going to return the index of the position where we should be inserting the student. Okay, cool. So I think that's it. So let's do some searching here. For example, let's say iterative. Int iterative is iterative search. And what do we need to send that? We need to send that students, and then the student number, and we also need to send it iterations, right? Let's call it count. I'm going to call it count. Okay, and I'm going to create count over here. So int count equals 0, and basically in iterative, it's going to, and let's call this count iter so that we know that it's for the iterative search, ITR. Okay, now let's create, for example, int count binary ITR. Okay, so in this case, we're going to say int binary ITR is equal to binary search iterative, and the same thing, we need to go students, student number, count binary iterative, and then let's do the last one is count binary recursive, and in that case it's going to be int binary recursive is equal to binary recursive search, binary search recursive. And okay, now for that one we need to send a bit more, right? So we've got to send the students, the student number, okay, the number of iterations, count bin rec, okay. Then we also need to send it the upper and lower bounds. So the upper bound is going to be the students dot size, right? That's the upper bound, and the lower bound right at the start is 0. Cool. So now we've got all of these different searches. Let's see out the difference between them. There may be a difference between these two. I'll find out now, and I will fix that very quickly. So let's just see out the iterative search, iterative. Then we'll see out the binary search, the binary iterative search, and then the binary recursive search. Okay, cool. So we now outputting each time we find this what the index would be if we did an iterative search, the binary search, and the binary recursive search. And let's g++ main.cpp, and oh, okay, so I've got some errors here. Let me actually make this font a little bit bigger, just so that it is visible. Okay, cool. What are my errors? Firstly, return equals. So that was quite dumb, and that's on line 41. Let's go up here. Okay, return students.size, and where else would we have this error function? Wait, let's just save here. Just a hunch here. Let's just see what happens if I do this. Okay, that was a bit weird. Okay, so basically because I said iterations plus plus, I would want to do it after it was called, which is it didn't like. Okay, but anyway, so we're built here, and we've got main.exe, so let's go here, main.exe, run that. And okay, so, whoa, hello. It looks like, firstly, this index for the recursive search is just one out, and so it was just that thing where this should be upper. We return the upper side. That would fix that one. Here we go. Let's take a look. Cool. And then the second one here is that this iterative search just doesn't work at all. The binary search using the iterative approach, right? So let's take a look at why. Okay, so found equals false, and let's see what. Oh, well, that would make sense, wouldn't it? I look to see whether the upper and lower difference is 1, and if it is, then I say found is true and I continue, but then I get out of the while loop and I don't actually return that point. So we should be returning upper right here. Okay, cool. Now let's take a look. So main, there we go, and now all of the indices are the same. Okay, cool. So we've done that. Now we need to actually keep track of the number of iterations that we're doing. Okay, so we're going to create an output file, and what we're going to write to the output file is the index. And what I would do is I would say that if iterative does not equal binary ITR, or iterative does not equal binary rec, then we have a problem, right? Because if your index from your iterative search is not equal to the index from your other searches, then we probably made a mistake somewhere. So let's just make an error here, error the iterative search does not return the same index as the binary search. Okay. And that's it, I think. Alright, cool. But if that's not the case, then we're going to output the iterative index, then we're going to output count ITR, and then we're going to output count. I'm going to do the recursive function, but they should have the same number of iterations. The binary search for the recursive binary search, or the iterative binary search. And then we just need to put some spaces between these, and that's it. That should be our file done. Let's just close up our files here. So search must also be closed, and output should be closed. Cool. Okay, let's build it and see what happens when we run it. All done. And if we look in this folder, here's output.txt. So for iterative search, the index and the number of iterations are the same. And for for binary search, you'll see that the index is correct, and the number of iterations taken for the binary search is about 14. And if we take log of 11,500, it should be quite close to 14. Let's take a look at that. Let's see if we try. Okay, we're using log 2, right? So we need to do 11,500, the log 10 of that, so log 10. And then we've got to divide it by the log of 2. And when we equal that, 13.5 roundabout. And if you look here, it's about 14 iterations, sometimes 13. So this is the best case, and that's kind of like worst case. It could get worse. There are cases where it would be a little bit worse, but you can see right here that in most cases it is between 13 and 14 searches, and that's it. Even when your iterative search had to compare 9,000 different students, this would only have to do it about 14 times. So I think that should clear it all up. Hopefully that does explain vector searching and sorting. There is the previous video of how to sort, and if you have any questions, please don't hesitate to paste it on this video or email me. Thanks.